Hello! In this video you'll learn how to describe the processes which convert sound waves in air into vibrations in solids, and you'll be able to explain why such processes only work over a limited frequency range, and use this to explain the way the human ear works. So, whenever you've got an object vibrating in air, it will create sound waves in the air. Here I'm showing a solid cone vibrating backwards and forwards in air, which causes the particles making up the air to squash together, then spread out. Where the air gets squashed together is called a compression, and where the air gets spread out is called a rarefaction. You can get marks for knowing that in your exams. If the sound waves then hit a solid object, it can travel through the solid by causing vibrations in the solid. For example, when sound waves enter the ear, the sound waves cause the eardrum and other solid parts to vibrate, which causes the sensation of sound. The conversion of sound waves to vibrations of solids only works over a limited frequency range. This restricts the limits of human hearing. Normal human hearing is from 20 Hz to 20,000 Hz. However, as you get older, the range narrows. For example, you might only be able to hear from 30 Hz to 15,000 Hz. This is usually because of wear and tear, such as listening to loud music through headphones. Let's look inside the ear and see what's going on, because you need to know this for your exams if you're studying triple physics or single physics. Sound vibrations are funneled into the ear canal by the outer ear, which is the part of the ear on the side of your head that you can see. Once the sound is inside the ear canal, the sound vibrations hit the eardrum and cause it to vibrate at the same frequency. It's important to know that the frequency never changes as it passes through the different mediums or the different parts of the ear. That's great because it means you always hear a good reproduction of the original sound. It would be no good if the parts of the ear changed the sound that you were trying to listen to. The vibrations from the eardrum make three tiny bones called ossicles vibrate. The bones amplify the vibrations, which means it makes the vibrations bigger. The reason the vibrations need to be bigger is because they are passed onto the cochlea, which is a structure about as big as a pea and shaped like a snail shell. It's filled with fluid. The vibrations make the fluid in the cochlea vibrate, which in turn makes tiny hairs on the cochlea walls vibrate. The hairs turn the vibrations into electrical signals called impulses, which are sent along the auditory nerve to the brain, which interprets the signals as sounds of different volumes depending on the intensity and different pitches depending on the frequency. High intensity is a loud sound. Low intensity is a quiet sound. High frequency is a high-pitched sound, and low frequency is a low-pitched sound. Different hairs detect different frequencies of sound. The hairs at the front of the cochlea detect high-pitched sound. The hairs in the middle of the cochlea detect medium-pitched sounds, such as a trumpet or human speech. And the hairs at the top of the cochlea, or at the back of the cochlea, detect low-pitched sounds such as a tuba or a bass drum. Now, the best way to remember which hairs detect what frequencies is by thinking about listening to a music concert from far away. If you're far away, the only sounds that you hear are the bassy, low-frequency sounds. The high-frequency sounds don't travel as far, so you don't hear them. That's why nature has made the cochlea detect the high-pitched sounds at the front of the cochlea, where they don't have to travel very far into the cochlea, mid-pitch sounds or mid-pitch notes in the middle of the cochlea because they can travel further, and low-pitch notes right at the top of the cochlea, right at the back of the cochlea, because they're capable of travelling the furthest. Clever, eh? Right, good luck with any physics exams you're sitting. I'll see you in the next video. And if you want to be successful in life, work hard and be nice.